Now let us quickly review the example of tossing two coins or tossing a single coin two times. We have already explained this process in our previous videos. Please refer to it. When we toss the coin for multiple number of times, then the list of the events also gets bigger. So it is not practical for us to calculate all the list of the events and then calculate the probability of the particular event. So to cope up with this problem, we make use of the rule in probability, the rule of addition and the rule of multiplication. First of all, we will see the rule of multiplication by the help of example. The rule of multiplication allows us to multiply the individual probability to get the probability of the events. The term and is an identifier for us to use the rule of multiplication, and actually it refers to the intersection of the events. As for example, the probability of A and B refers to probability of A intersection B, or we simply write it as probability of AB. We know that the probability of getting head is equals to 0.5 or 50%, and probability of getting tail is also equal to 50%, and sum of the probabilities in this case is equals to 1. Therefore, the probability of the event head is equals to the probability of head into probability of head, which is equal to 0.5 into 0.5, which is equals to 0.25%. Later on, we'll explore that if the rule of multiplication holds, then the events involved are independent. We'll use the rule of multiplication as the test of independence as well. Similarly, to find the probability of a head and the tail, it equals to the probability of a head into probability of tail. We are using the multiplication rule, and this is equals to again 0.5 into 0.5, which is again equal to 25%. Here we use the multiplication rule to calculate the probability of the event, and we see that the results are same when we compare it to the previous example. Similarly, the probability of tail and the tail is equals to the probability of tail into the probability of tail, which is again equal to 25%. If the probability of A intersection B, meaning thereby if the probability of AB is equals to probability of A into probability of B, then we can say that the events A and B are independent. We will explore this topic in greater detail in our next videos. Now let us generalize the multiplication rule. The probability of intersection of the events, if it is equal to their individual product of their individual probabilities, then we can say that the events are independent of each other. In other words, the independent events, the intersection of their probabilities is equal to the product of their individual probabilities. Now let us see another rule, the rule of addition, and when the word or is, for example, A or B is used, we use this rule of addition, and it is used in the case of a union, or it is denoted by the union. Is, for example, probability of A union B, and so on. With reference to the earlier example, the probability of getting head and tail or tail and head, this is equal to the probability of head tail plus probability of tail head. Notice that the events head tail and tail head, they are mutually exclusive events. And we have already seen that the probability of head and tail is equals to the probability of head into probability of tail plus the probability of tail and head is equals to the probability of tail into the probability of head. We are using the multiplication rule. And we have seen that the events head tail and the tail head, they are mutually exclusive events as well as the equally likely events, so they have the same probability of 25%, and if we take twice the 25%, the total probability is actually 50%. Now let us generalize the rule of addition. The probability of mutually exclusive events, the union of the mutually exclusive events, this is equal to the sum of their individual probability. Iterate it once again, the probability of union of mutually exclusive events is equals to the sum of their individual probabilities. Let us see a very simple example. When we toss a coin and we want to find a probability of getting head or tail. So the probability of getting head plus probability of getting tail, and one of the event is certain. That is why the probability of getting head or tail should be equal to 1. It is very obvious. And one important thing to remember is that the addition rule applies to the mutually exclusive events. And here, head and tail are the mutually exclusive events. Now, through the example of rolling two dice, we will see or we'll plot the graph of the random variable. And the random variable that we are going to consider is the sum of the numbers that appear when rolling two dice. Let us assume that the dice contains a number from 1 to 6. So we are going to draw the cross product of numbers from 1 to 6. So we are going to get 6 into 6 events in total, and it is equivalent to naming the position of the 6 into 6 matrix, 6 rows and 6 columns, and in total we have 36 unique events. So the probability, each of these events are equally likely. So the probability of each event is equals to 1 by 36. Random variable is the sum of the numbers when we roll two dice. So the minimum value is equals to 2 and the maximum value is equals to 12. So let us draw a table with the minimum value of 2 and it increases by 1 every time until it reaches 12. And let us list out all the possible events to this table and assign their frequency. There is one event 1 1 that adds up to 2, and there are two events 1 2 and 2 1 that adds up to 3. And we are going to assign all these list accordingly until we reach the sum to 12, and we will plot a graph and that resembles to the normal distribution. The frequency will reach maximum when the sum is 7, and at this point the frequency will be symmetric and the graph is nearly looking like a normal distribution. If we consider the random variable x is our x-axis and the frequency is y-axis, we will get the normal distribution and centered at the mean 7. If we consider the frequency as the height and the random variable as its base, and if we try to enclose it by the curve, then it seems like the normal curve. And this normal curve is symmetric at point 7. Now let us plot this information in a graph where our x-axis represents the random variable, that is the sum of the numbers when we roll two die, and our y-axis, it represents the frequency, and the minimum value for the random variable is 2 and the maximum value is 12, and it is centered at 7, and we will get a normal distribution symmetric at mean 7. As all the possible events are mutually exclusive events, we can always use the addition rule. Also, we can use the multiplication rule in order to identify whether the events are mutual, whether the events are independent or not. When rolling a die with number 1 to 6, each of these events are equally likely. So the probability of getting 1 or any number from 1 to 6, they are equal. That is equals, the probability is equals to 1 by 6. The probability of getting 1 2 or 2 1 is equals to 1 by 36 plus 1 by 36 is equals to 2 by 36. We can calculate the probability of remaining parts in a similar manner. So this is it for this tutorial. Thank you very much for your time. Thank you very much, Econometrics Melody.